Hello, welcome back for the series Publish Your Own Library. So part 4 is about testing. So obviously if you followed from day 1, you would be familiar to the code base. If you're not, I invite you to watch the previous videos, otherwise it's gonna be a little bit hairy for you to understand what we are testing. And obviously when you're testing a code base, you need to fully understand what you're testing, otherwise you're gonna miss some edge cases. If you enjoyed the video, like and subscribe. As usual, I'm very sorry about my noisy voice. I got a cold, hope it won't disturb you too much. Right, enjoy the video, see ya. Okay, so our printer has only one interface and one implementation, so as general rules, we test implementation and public method. So the goal of today is just to test that public method. So we start by creating a timber_test.go file. The package is timber_test. So if your package was blah, it would be blah_test. So today we will just use the testing package, native package from Golang, because it's really easy to understand and you don't need extra libraries or whatsoever. So that you can see just how you fail a test, t.error with a message. So just a tip, usually it's quite good to have your implementation on one side and your test on the other side, so then you can see what's the control flow that you're testing, so then you don't miss any edge cases and you're thoroughly testing. So here the font is a bit big because for the videos I make it bigger. So we will have this framework for our test today. So you have usually test the happy path with we will test everything we built in the previous videos, the pipes, the recursion and everything, and we will use that framework given, when, then. So given is the setup, when is the action, and then is your expectations and assertion. So I really encourage you to use that because it gives you the mind frame to write thorough tests and clear tests, and that doesn't matter if you leave the comments in your test, so then it's clear for a reader, for someone who's gonna extend your test. So here you can see that I need those node tree that we created in the first video. So I will just create a package called example. We call it timber example. So I just need like the branch and the leaf struct we created previously. So leaf, branch, which comply to that composite pattern interface. So if you don't remember, have a refresher if you need. But they were living in the main main.go that I use for actually testing, but now we need to write proper automated tests. So there you go. So we will have our branch, and we can just start with a branch with only one leaf, for instance. So you can see there that my ID is giving me some help. So label components are private fields from that timber example package, so I'm gonna have to change that in a minute. An exported label usage, meaning that they are private. So here I could do it because they are living in the main, but not here because I could provide a constructor for them, but it's just for example. So we will just make them public for now. So label capital case for branch as well, and components, there will be a clash because there's a function called components, so it will be confused, so we can rename it items with a capital I. So coming back here, label, and then items, and then for the leaf it's the same. So we have a very simple tree there. We can rename the labels branch and leaf. Okay, so our setup, we need a tree, and our printer is we need a printer essentially. So if you remember, we created a default printer constructor in the previous video. So that's our setup, and then the action is just to invoke the function we are testing, which is .print. Okay. So we will get an interface and an error from that. So we can assign that to variables, and then this is where we will have our assertion. So it's a success case, so we are expecting the error not to be nil, and then the result we will see later, but just for the sake of showing you, we can have a failed test. Just a disclaimer here, usually you do TDD in this kind of scenario, but the previous videos were mainly for education purpose. Okay, so here you can see that the to do, when I run the test, you can see to do, which is the error message that we put. Here it's a good idea we will have a lot of those. If something is different from that, then testing framework errors. So it's a good idea just to create a really quick function in your test there. So we will just call it equal, and then you have to send your testing.t, which is your framework runner. So if your expected value is different from your received value, then we will craft a nice message. So we wanted a value, then breaking line, then we received colon space a value, and so then the first value is your expected, and then your second value is the received. So then we can try that out. We can rename expected to wanted, so then you have matching syntax. So to invoke it, it's just equal t nil error. So you can see that the idea is really helping there, telling you which one is wanted, which one is received, if you have a nil value or string. There you go. So wanted is not really a line, so we're gonna add a line break in front of wanted. There you go. So if we run that again, okay, so you can see that it received a slice. So if we put a tab in front of the values like that, there will be a line on the same tab. There you go. It's really nice. So you receive that, but you wanted that. So really easy to write, and you could make your own testing package or library like that if you don't want to repeat yourself or write these kind of things all the time. So our result is actually a slice. So we can try that out. It won't really work because there will be some casting problem. So branch and then leaf. There you go. Need to be double quote, so you can try that out. There you go. It's panicking because it can't really, it's not like a really advanced deep comparer, so it won't work. So it's okay, we can go back to very simple. So when you have a slice, you can try the you can try the length, and then you can try the each element, sorry. So yeah, that's fine. I was just trying to cast and to see if I could make it, but it's fine. So I still need to cast it because I'm about to invoke length and query each element, which are properties of slice. So I need to cast it to a slice first. So you can see that I made a tiny mistake. So what I want is 2 and then the length. So it's written line 34 and 35 are written the other way around. So I need to change that. There you go. So what I want is 2, and it's coming from length casted result. And what I want is pipe branch, and that's coming from casted result element 0, first item. There you go. A little bit tedious, but very simple and effective. So if we try that out, it should now pass. There you go. And it's logging branch leaf because that's our default printer, if you remember. So it did pass in 0 seconds, probably milliseconds, because it's really simple. So that's a simple test case. So you can label your tests with underscore and then lowercase your test. Here is just a quack. That's not a problem. There you go. So test failure doesn't have anything, but it still runs. Again, you need to have test in front of your function to be runnable. Capital T-E-S-T. That's how Go detect that you're running a test. Okay, so we obviously have a lot of edge cases there. So do you remember all those pipes configuration from the previous videos? So when there's a child which is not the last, and when there's a last child, the pipes are not the same, and so we need at least a branch within a branch having some items. So branch 2, leaf 2, and you can put another leaf to test the different pipe. There you go. So you have different length and different pipes. So obviously all of those are not working anymore. So we can it's a bit tedious, as I said, but it's thoroughly tested. So the length now is 5. So I can change that. Branch 2, leaf 2, and leaf 3. There you go. And the last leaf didn't change, but I just wanted to make sure. And if I run that, it's all passing. It's okay. So it's not simple anymore. I could have kept the previous branch and leaf together, but essentially we're testing a more complex scenario now, so that's gonna be our happy path, as we said. Okay, so back to the code. Let's see if we have any edge case to test. So we tested simple tree, a more complex tree. So it's a good idea to test an empty tree, just to make sure that 0 value won't break your code. So it should still be a happy path, so it's gonna be under the label success. Can name it empty tree, so the tree is just a branch, an empty branch. Okay, let's just see what happened. Oh, so there you can see, yeah, obviously you have a length problem, but it has also written something interesting, just a 90-degree pipe. So you can see that if we would have done TDD first, we would have spotted that funny thing. It's okay, so we will just write test to cover it. So it's not 0, so it's still returning a slice of one item, so that's interesting. And the item is just a bended 90 degrees pipe, so we will just test that. That's maybe like a thing to fix in the future for our library, because if you're providing an empty tree, maybe you don't want to log the pipe or start with something else for the first item, or it's okay. It's not the end of the world. Okay, so that's all good. So yeah, so that first test is the complex scenario. We're also covering a simple scenario. So you can see here all the label, complex pass, and empty tree pass. Okay, so back to the code. So you can see that the code, the print function can fail at two places: the printer function and the result function. So it's okay. So we will now flesh out our fail functions. So if you grab that body, we will have to change the constructor. So the constructor, we will now use the custom printer, not the default printer, because we want to send faulty function. So you see all the point of refactoring in the previous video. So we will craft our faulty print function, so it can still log if you want, but instead of returning nil as an error, we will now create send our own error. So real life scenario is the user having, so the body is very simple, the body of that function is very simple, but a user of your library can have everything he wants and having some control error, and it might happen that it returns an error. So alright, so that test case is the printer function failure. Let's see. There you go. So it wanted nil, but it received an error, which makes sense. So here, if you bluntly replace by the error message, you will have that curious message: wanted BAM but received BAM. So it's because it's a type mismatch. So you have to invoke .error on your error, which is casting to a string. So there you have a cast problem on the result, because if there's an error, we are returning nil. And there you go. Still printing that funny pipe. That's alright. So you can see how useful our equal function is, because otherwise we would have to type that again and again. So now we will do the same with your result function. So as a reminder, that was your aggregator for your result, to spit out the result, the final result from your recursion loop. So here you start understanding the drill. So we just change the test function name, and then we will change that, we will send our custom faulty result function. So faulty result function. So here another general rule: you don't want to test multiple things at the same time, because you might have false positive. So here I'm putting back the default printer function, but sending a faulty result function. Always test things atomically, one by one. And here I can return nothing and then an error. And here it's a good practice to send a different error, just in case you have transient error or false positive. So then you receive boom, and so then you know that you are not leaking from the previous test. And then you go. My idea, let me run a single test at a time if I want, but if I run them all, you can see that printf and failure all good and result function all good. So there you go. Alright, so hope you enjoyed that testing adventure. So as I said in the video, usually you do TDD, write your tests first, and then we will build it, instead of going the other way around, like building the code and have to refactor and so on. But you will understand that it's just for education purposes. So hope you enjoyed that video, and bear in mind that testing is like coding, so don't disregard your testing. Treat your test as first-class citizen, and think about your teammates and colleagues and your future self. Write it really cleanly. So I give you some general rules there. So given, when, then, testing the happy path first, then the failures, and having the code on the side so then you don't miss any edge cases. So if you apply those simple little tips, that recipe all the time, you will have better and better code. Alright, so happy coding everyone, see you next week, ciao.